everywhere. How to overcome DC offset? So yeah, you know that capacitor will block your DC and allow only AC. So putting a capacitor in series with the circuit will enable to suppress your DC. So one simple path is have a capacitor in series and resistor in shunt. So simple circuit which can ensure that the DC is completely blocked at the LPF itself. It does not go beyond the mixer. So receivers having zero IF, you must have some sort of mechanism to cancel out DC in the in phase and quadrature phase path. So LO leakage is a serious issue. Because of LO leakage, I'm having DC offset also. So you have to have methods to overcome the effect of DC offset also. So as I said, you have a AC's capacitor resistor combination circuit to bias and eliminate the effect of DC. Such a network will also remove a fraction of signal spectrum below the zero. Suppose that your signal is having information at the zero DC frequency, that will also be removed here. So more than the unwanted DC, the useful DC available in the input is also getting replaced, because getting removed because of this capacitor resistor arrangement. So when we are designing circuits to remove the noise, if there is a signal at the DC frequency, that is also getting removed. So which is a drawback for us. So as a thumb rule, ensure that the cutoff frequency of the filter should be less than 1/10 of the symbol rate for negligible ISI. So if you want to ensure that the DC offset has to be removed and signal should not be removed, then this condition should be satisfied. The cutoff frequency of HPF should be less than 1000th of the symbol rate for negligible ISI. So in this case, the DC offset because of the yellow leakage can be completely eliminated to some extent. In practice, careful simulations are necessary to determine the value of F1 for a given modulation scheme. So what F1 value you are going to choose for a scheme will determine whether your DC offset is eliminated or not from the circuit. So the importance is given to the designing the frequency F1. So when you have an on-chip system for that, it is going to be easy for you. If you are going to use a GSM, then extremely large capacitors are required, because the frequency, corner frequency will be around 20 to 30 hertz only. So you know F is equal to 1 by 2 pi RC. When F is very small, C will be very large. So you cannot have an on-chip capacitor for such a large amount of value of capacitance. So note that the quadrature mixers require 4 high-pass networks in the differential output. So since we are going to use I and Q mixers, you definitely have to have more number of high-pass networks for eliminating your DC. GSM, we have seen the frequency is very less, but on the other case for WLAN, the corner frequency is 20 kilohertz. So with that, you can easily have an on-chip capacitor for integration. And also, the third order distortion results in compression and intermodulation. So direct conversion receivers are additionally sensitive to even order nonlinearity. uh, in the non-linearity we have seen, first order is going to be a fundamental signal, second order will produce a DC and your original signal, and third order is going to produce your IP3, right? So here in uh, this type of receiver, this even order distortion is also going to cause effect, because it is going to provide unwanted